What if I tell you your entire country's internet depends on a few hair-thin glass fibers lying deep under the ocean? And if just a few of them break, your internet, your calls, your connection to the world could disappear in seconds. Sounds crazy, right? But this is not science fiction. This is how the internet actually works. And today, we're going deep under the ocean, inside cables, inside light itself, to understand the invisible system that powers your digital life. I'm Irfan, and you're watching the Verience Degree. And right now, every message you send, every video you watch, every call you make is traveling through something called optical fiber. Not satellites, not Wi-Fi towers. Light inside glass. More than 95% of the world's internet traffic travels through submarine cables made of optical fiber. These cables stretch across oceans, connecting continents like a giant invisible web. In fact, the total length of optical fiber on Earth is estimated to be over 5 billion kilometers. That's more than the distance from Earth to Pluto. Let that sink in. But have you ever wondered, how does data actually travel through light? Let's simplify this. Imagine two people standing far away from each other. They both have laser lights, but there's a rule. They cannot talk, they cannot use gestures, they can only use light. So how will they communicate? By turning the light on and off. One pulse means 1. No light means 0. This is called binary. Now they can create patterns. 2 quick pulses could mean A, another pattern could mean B, and just like that, they can send information using light. In real life, everything you see online, videos, audio, images, text, all of it is converted into zeros and ones. Even this video, even your messages, everything is just binary. And these binary signals are sent as light pulses through optical fiber. Now here's the real question. If light is traveling through glass, why doesn't it escape from the sides? The answer is a physics concept called total internal reflection. When light hits the boundary at a certain angle, instead of escaping, it reflects back inside, again and again, like a perfectly controlled bounce. This allows light to travel long distances inside the fiber without leaking. This idea is not new. In the 1840s, scientist John Tyndall showed that light could travel through curved streams of water. Later, in the 1950s, Narinder Singh Kapani developed early fiber systems. But there was a huge problem: signal loss. The light became weak too quickly. Many people believed optical communication would never become practical. Then came Charles Cow. In 1966, he proved something revolutionary. If ultra-pure glass could be created, signal loss could be reduced dramatically. That discovery changed everything. Because of his work, Charles Cow became known as the father of fiber optic communication. In 1970, scientists at Corning successfully created ultra-pure silicon glass. Now the signal could travel much farther. Then another problem was solved: light leakage. The solution was cladding, a special layer around the fiber that keeps the light trapped inside. And finally, optical fiber became practical for communication. In 1977, optical fiber was used in telephone networks for the first time, and the results shocked everyone. A single optical fiber could carry more data than thousands of copper wires. That was the moment the world changed. An optical fiber cable has multiple layers. At the center is the core. That's where the light travels. Around it is the cladding, then protective coating layers, and finally an outer jacket. For submarine cables, the structure becomes much stronger. Steel protection layers are added, and even copper tubes, because these cables lie deep under the ocean, facing pressure, currents, earthquakes, and ship anchors. Yet somehow, they keep the world connected. Inside these cables, there are devices called repeaters, placed roughly every 70 kilometers. Their job is simple: boost weak signals. But here's the interesting part. How do they get electricity in the middle of the ocean? Through copper tubes inside the cable itself. Yes, electricity flows across oceans. Here's another challenge. How can one fiber send and receive data at the same time? Wouldn't the signals collide? The solution is different wavelengths. One wavelength is used for sending, another wavelength is used for receiving. This allows two-way communication inside the same fiber. To increase speed even more, engineers use something called wavelength division multiplexing, or WDM. This technology combines multiple signals into one single fiber, like combining many colors into one beam of light, then separating them again at the destination. This massively increases internet capacity. But no system is perfect. Even in ultra-pure glass, some signal loss still happens because of absorption, tiny impurities, and scattering. And remember, some submarine cables are over 6,000 kilometers long. so signal weakening becomes a serious problem. That's why repeaters are extremely important. Now think about this. Every 3 days on average, a fault occurs somewhere in submarine cables around the world. Repairing a single fault can cost millions of dollars. Maintaining this global network costs billions every year. So where does all that money come from? From us, the internet bills we pay every month. That money mostly goes to companies maintaining optical fiber infrastructure, not directly to platforms like YouTube or Netflix. That's why you still need separate subscriptions for streaming services. Now imagine something terrifying. Some countries depend on only a few submarine cables. If those cables fail, the entire country could lose internet access, disconnected from the world, all because of a few hair-thin strands of glass. Even today, more than 95% of global internet traffic depends on optical fiber, but companies like Starlink are trying to change that, using satellites, internet from space. If successful, the future of global communication could look very different. At the same time, NASA's Artemis program is preparing to send humans back to the moon, with plans for long-term lunar missions and eventually human missions to Mars. So next time you watch a video or send a message, remember this: it's not magic, it's light, traveling through glass, across oceans, connecting the world. If you enjoyed this video, subscribe to Verience Degree and become part of this journey into the unseen world.